Good morning, students. Very good morning. Okay. Good morning. So, periodic classification of elements, right? So that's what we were discussing in the last class. Yes, yes. Good morning to everyone. So, can anyone send me the words about the concept we have discussed in the last class? About what we had discussed in the last class? Can anyone? Just you can send me the words. Hmm? Okay, very good. Modern periodic law. Then, limitation of Mendeleev's periodic table. Very good. Then, Henry Moseley's experiment. Very good. Yes, all of you are correct. So, we have discussed about the Mendeleev's periodic table. So, we have discussed about the Mendeleev's periodic table. That means periodic law, where under this we have discussed about periodic table and its limitations right? So that's what we have discussed, one of the concept. Yes, all of you are right, very good. Okay, so when I am talking about Mendeleev's periodic law, what it tells that physical or chemical property, or I can straight away tell that properties of the elements will be decided by the atomic weight, right? So properties of the element will be the periodic functions of their atomic weight. So that's where we have the periodic law with respect to Mendeleev's periodic law. Okay na? So that's where he is relating properties of the element with respect to the mass of the element. So that's where we have the Mendeleev's periodic law, and that will be the feature of the Mendeleev's periodic table also, because it is based on the Mendeleev's periodic law. So Mendeleev's periodic table is based on the Mendeleev's periodic law. So even that can be included as one of the feature of Mendeleev's periodic table. That is one thing. Second point here is he kept some of the empty spaces. He kept some of the spaces so that in future if any element will be discovered, they can occupy those places. That's where we should appreciate his work, Mendeleev's work, right? So that's where we have the Eka aluminium and Eka silicon, right? Gallium and germanium. That's where we have the another important features of Mendeleev's periodic table. Then very important point here is he makes sure that all those elements which are having similar properties, they should occupy a vertical column, which he called it as families. Okay, so that is the groups. So that's where we should have the features of the Mendeleev's periodic table. So these are the three parts. Now when it comes to limitations of Mendeleev's periodic table here is first and foremost one, once again, it is based on the Mendeleev's periodic law, where it talks about atomic weight. That is the major limitation of Mendeleev's periodic table. That is one thing. Second point, since it is based on the atomic weight, naturally he didn't discuss about what about the isotopes. Sorry, what about the isotopes? Because many elements in the nature they have their isotopes, which differs in their atomic weight. So whether all of them they will occupy different places, that's what he has not discussed. That is another major limitations of Mendeleev's periodic table. And the last one is he didn't talk about position of hydrogen. Position of hydrogen, but those two are major one. So first one is it is based on the Mendeleev's periodic law. That means where he talks about atomic weight. Then second major one is there is no discussion about the position of the isotopes. So these are the major points with related to limitations. Fine? All of you have understood? So that's why we have the Mendeleev's periodic table, its feature and its limitations. Okay? Then once we did with this, we went to modern periodic law. Before that we discussed about Moseley's experiment, where he took frequency of square root of the frequency of X-rays versus atomic number or and atomic mass or atomic weight. So that's what he did. What he did, he took the frequency, square root of frequency of X-ray, square root in the sense while plotting the graph. Okay, so frequency of X radiations and versus atomic number and atomic mass. To his surprise, he observed that with related to atomic number, he got a straight line in his graph. But with respect to atomic weight, atomic mass, he didn't receive any straight line. He didn't got any straight line. So based on that, that's where people came to know it's not the atomic weight which is going to decide the properties of the element. It is the atomic number which is going to decide. That's where Henry Moseley's experiment is bit important. Okay? So because of that, there came the modern periodic law. There came the modern periodic law. Okay? Now, modern periodic law, naturally it is based on Mendeleev's periodic table, which was in the beginning he gave that one. So based on that one, they have followed with modern periodic law. But only thing here is, here elements are arranged based on their atomic number. That's what modern periodic law talks about. It tells that properties of the element will be the periodic functions of their atomic number, not the atomic weight. That is the difference between Mendeleev's periodic law and modern periodic law. All of you have understood? So these are the points what we have discussed in the last class. Any doubts in this? Any doubts? Okay. So we have discussed about modern periodic law. Now we will come to periodic table. Modern periodic table, which is also called as long form of periodic table. Which is also called as long form of periodic table. Okay? Okay, fine. So in that case, we will move to modern periodic table. Okay? So which is also called as long form of periodic table. Okay? Now, as the name itself suggests, in this periodic table they have kept the space for the element to be included in future if they are discovered. Okay? So that's why they are called as long form of periodic table. Okay? So modern periodic table, one of the important feature of modern periodic table is it is based on modern periodic law. It is based on modern periodic law, because where it talks about atomic number. It talks about atomic number. Okay. So what I mean to tell here is modern periodic table is based on the modern periodic law, where it talks about the atomic number. Now no more atomic mass. It will be atomic number which will be given importance. So I mean to tell with respect to properties of the element. Okay. So that's where we have the atomic number. So therefore modern periodic table and Mendeleev's periodic table, that is the difference. In Mendeleev's periodic table and many other things which we have discussed, everywhere it is atomic weight, but here it is atomic number. That is one thing. Now another important feature of modern periodic table will be, it will be composed of groups and period. It will be made up of groups and periods. Okay. Now when I am talking about the groups, they are nothing but vertical columns. They are nothing but vertical columns present in the periodic table. So groups are nothing but vertical columns present in the periodic table, right? So like this it will be present. That's why they are called as vertical columns. Fine. Now groups are also called as, yes, groups are also called as vertical columns, or groups are also called as families. Groups are also called as families. What I mean to tell here is, those elements which are present in a particular group, they are called as families. Yes, Rohan, that vertical line I have drawn just to indicate that it is the vertical columns. So in the examination, no need to write all those picture and all. Okay. So that's where we have the groups which are vertical columns, and those elements which are present in those particular column will be considered as families. What is the speciality of the family? Yes, Dikshit, I know now you are going to send 3-4 messages. Yes, good morning. So what is that families? What is the feature of a family? For example, if you take my house, there will be some similarity among my mother, my father, myself and my son, because we are one family. We have some genetic relation, right? So the same logic is applicable here also. So family means there will be similarities. There will be similarities. So what I mean to tell here is, elements present in a group, elements present in a group will have similar properties. Will have similar properties. Okay, that is the speciality of the groups. All of you have understood? So groups are nothing but vertical columns. Those elements present in a particular group will be considered as families, and those elements will be having similar properties, and due to that they will be considered as a families. Fine? All of you have understood? Now, why they should have similar properties? Please remember, I am not mentioning same properties. No. I am telling similar. That is the difference between same and similar. Same means there is no change. But similar means there is some similarity, but there is an option for changes also. So therefore you should use the word similar properties, don't write same properties. Okay? So that's where we have the groups. Why they should have similar properties? Especially I am talking about their chemical properties. Why they should have similar properties? Yes, Rohan, you are absolutely correct. Because they have similar outer electronic configuration. They have similar outer electronic configuration. Okay, so all of you can see So they are having similar properties. That is because they have similar outer electronic configuration. Anyway, we are going to discuss all these things in detail. But for time being, you should remember that modern periodic table is composed of families, that is groups, and periods. Now when I am talking about the groups, where elements will have the similar properties present in a particular groups. What is the reason? Because they have same or similar, not same, sorry, similar outer electronic configuration. Yes, Vishwas, very good. Because they have similar outer electronic configuration. Fine. So I am not talking about electronic configuration. I am talking about outer electronic configuration. That means they should have same number of valence electron. Now I can use the word same. They should have the same number of valence electron. Right? So what I meant to tell here is I have written 3 points. 1, 2, 3. Okay? So for point 1, answer is point 2. Why elements will be having similar properties? Answer is 2. Because similar outer electronic configuration. Okay? So in that case, when they have similar outer electronic configuration, that indicates that all of them, they should have same number of valence electron or outermost electron. So what do you mean by valence electron? So these are the electrons present in outermost shell. They are called as valence electrons. All of you have understood that is the speciality of the groups. And in the modern periodic table, we have nearly 1 to 18 groups. It starts from 1 and it ends up at 18. Okay? So old nomenclature is also there, where we are going with Roman numbers, but we will go with modern one, 1 to 18. Simple one, 1 to 18. Total groups will be 1 to 18. Fine? All of you have understood? So now we will come to hydrogen family to inert gas. Yes, absolutely correct. That's where there is a problem with hydrogen family. Anyway, we are going to discuss with that. Now we will come to periods. When I am talking about the periods, now these are the horizontal rows. These are the horizontal rows. That means we can imagine this one as the horizontal rows. Vertical column, horizontal rows. That's where we have the periods. Hagadre, when I am talking about the periods, yes, Dikshit. So when I am talking about the periods, now those elements present in a periods, they will not have similar properties. Please remember, they don't have similar properties. Elements will don't have similar properties. Don't have similar properties. Okay, therefore it's not called as families. Elements present in a particular period will not be considered as families. All of you have understood? Okay? And in the modern periodic table, we have somewhere around 7 number of periods. We have nearly 7 number of periods. Okay? Now, when I am talking about period 1, try to understand this one. So when I am talking about period 1, that indicates that I am talking about outer energy level, 1. When I am talking about period number 2, then I am dealing with outer energy level 2. Same way, when I am talking about period number 7, that means I am talking about outer energy level 7. Got my point? So what I mean to tell here is, in the modern periodic table, when I am moving from period 1 to period 2, So period 1 to period 2, then period 3, then period 4, 5, 6, 7, like that it will go on. That means when I am talking about period 1, when I am moving to period number 2, that means from energy level 1, I am moving to energy level 2. When I am moving from period number 2 to period number 3, that means I am moving from energy level 2 to energy level 3. Got my point? So what I mean to tell here is, if I take period number 1, here hydrogen and helium will come. Okay? So now this is the hydrogen and helium. Only one energy level. Why? Because hydrogen is having 1 electron, helium is having 2 electron. So 1 electron, 2 electron. Now all of us we know that. Please try to understand. If you are getting confused, let me know. Okay? So when I am talking about period 1, we have hydrogen and helium as the elements in period number 1. Now hydrogen is having 1 electron and helium is having 2 electron. So which is that subshell which is available at energy level 1? In atomic structure we have discussed. Any one of you? Which is that subshell which is available at energy level 1? Any one of you? Name of the subshell. You can just mention the symbol. Which is that subshell? Yes, both of you are correct. So there will be availability of S subshell only. There will be availability of S subshell only. That means S subshell is having how many orbitals? S subshell is having how many orbitals? Any one of you? S subshell is having how many orbitals? Anyone? Yes, all of you are right, and it should be small s, no doubt. So which is that? How many orbitals are present? No, it cannot be 2. I am not talking about electrons. I am talking about orbital. It is only 1 orbital. S subshell is having only 1 orbital, not 2. Make it correct, not 2. I am not talking about total number of electrons. I am talking about the orbital. Okay? So S subshell will be having 1 orbital. So maximum 2 electron will be accommodated in a orbital. So therefore, period number 1 should contain 2 elements only. Okay? So that is hydrogen and helium. Period number 1 should contain only 2 elements only. That is because there is availability of only S subshell, energy level 1. Okay? Now, when I am moving to period number 2, that's where lithium will start. That's where it will start from lithium and it will go up to neon. That's where I have the lithium, then it will go up to neon. Okay? Now, what is the atomic number of lithium? Lithium is 3. Atomic number of lithium is 3. What is the atomic number of neon? It is 10. Atomic number of neon is 10. So what I mean to tell here is, when I am talking about lithium, we have energy level 2. 2 electrons in energy level 1, 1 electron in energy level 2. Okay? Now, when I am talking about neon, yes, all of you are correct. Atomic number of neon should be 10 and lithium should be 3. Very good. So now, when I am talking about period number 2, I am talking about energy level 2. So in case of lithium, I have energy level 1, energy level 2. Outermost energy level is 2. Same logic is applicable for neon also. Where I have 2 energy level, where highest energy level is 2. Now which will be having 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. Got my point? So why they have the 8 electrons? Because when I am talking about energy level 2, there is availability of S and P. There is availability of S and P. So how many orbitals are present in S1? How many are there in P3? So 1, 2, 3, 4, 5, 6, 7, 8. So total 8 electrons. So total 8 electrons. So therefore, when I am talking about period number 2, it can accommodate maximum 8 elements. When I am talking about period number 2, it will be having maximum 8 elements. All of you have understood? So that's where we should understand with respect to periods. So period 1 indicates energy level 1, period 2 indicates energy level 2, and period 3 indicates energy level 3. Yes, Dikshit, there will be presence of 8 elements. Okay, further we will go. Now, to understand the next one, you should know of Bohr diagram. See, how much importance is there for of Bohr diagram. For next one to explain, because students will get confused. Sir, in that case, when I am moving to period number 3, there is availability of D subshell. Right? That's what they think. Because when I am moving about period number 3, so that means I am talking about sodium. And it will go up to argon. Now when I am talking about sodium, it is 11. When I am talking about argon, it is 80. Sir, what is this? What is happening? Here also it looks like there will be presence of 8 elements only. But you told me that periods are nothing but energy level. But here, when I am talking about energy level, 1, there is S subshell which is available. 2, S and P is available. 3, there is availability of SPD. Then D10, P6, then S2. So total element would have been 18, no sir. But why the hell only 8 elements are there in period number 3? So that's where you should know of Bohr diagram. So 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, like that. Even 6s are there. 6p, 7d, 7f. Oh, sorry. Why I wrote 7, I don't know. So it should be 6. Okay. So 6d, 6f, 7s, 7p, 7d, 7f. Now, first 1s will be filled up. Second, 2s will be filled up. Then 2p, then 3s, then 3p. Observe it carefully. Before 3d comes, what is happening? 4s will get filled up. That means next energy level will be filled up. Got my point? So before 3d, 4s is getting filled up. So therefore, although we are talking about period number 3, there is no D subshell, because before entry of the D subshell, 4s subshell is getting filled up. Afterwards only 3d will come. So therefore, here also S and P is going to get filled up. Here also 3s and 3p will get filled up. So here it will be 2s2, 2p6. Here it will be 1s2. Then here it will be 3s2, 3p6, which will be filled up, completely filled. S subshell is also filled, P subshell is also filled. All of you have understood? That's what it will happen. Now when we move to the next one, that is period number 4. When you move to the next one, that is period number 4. Now can you tell me how many elements you can expect over here? In period number 4, you can see the F4 diagram and you can tell me how many elements you are going to expect. How many elements you are going to expect in period number 4? Don't worry about the element. It starts from potassium and it ends up at krypton. So don't worry about the elements. Just tell me how many elements they are going to accommodate. Yes, Rohan, it should be 18. It's very simple because 4s, we are moving to energy period number 4 means we have moved to energy level 4. So 4, 3D, 4P. So these are the 3 which will be getting filled up. These are the 3 which I have to fill up. So therefore, S subshell will have how many orbitals? 1 and 2. 4p, how many orbitals? It will be having 3, therefore maximum 6. Then D, that is 3D. That is 3D, which is having 5 orbitals. 1, 2, 3. This is not the way to fill it up. Okay? Since I am thinking that all the orbitals are occupied, so that's why I have filled like that. So how many electrons you can expect? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That is because total 10 electrons over here, total 6 electrons over here, total 2 electrons over here. So therefore, period number 4 will have total number of 18 elements. Period number 4 will have total number of 18 elements. Now in that case, so 18 electrons are 18 elements. Now same way, can you tell me for period number 5? Can you tell me for period number 5? How many elements can be accommodated when it comes to period number 5? Anyone? Period number 5, how many elements? Yes, once again it will be 18 elements, because when I am talking about period number 5, these are the one which will get occupied or which will be filled. 5s, 4d and 5p. 5s, 4d and 5p, because after 5s this is 4d, then 5p. 6s will not come in period number 5 because 6 go for energy level 6, that means period number 6. So that's where once again in period number 5, 18 elements, because once again we have 5s, 5p and 4d. 2 electrons, 6 electrons, 10 electrons. Now can you tell me what about period number 6? How many elements you are going to expect? Period number 6. How many elements you are going to expect? No, Pooja. Oh, I think you are talking about old one. I don't know. But Chidwan is right. It should be 32 element, because when I am talking about period number 6, I am moving to energy level 6. So that means these many elements have to be filled up. These many orbitals have to be filled up. So this is for period number 4. This is for period number 5. This is for period number 6. So how many are there? 6s, 6p, 5d, then 4f. Right? So 6s, 4f, 5d, 6p. 6s, 6p, 5d, 4f. So 2 electron, 6 electrons, then 10 electrons, then 14 electrons. Altogether 32 elements. Altogether 32 elements. What about period number 7? What about period number 7? How many elements you are going to expect? Period number 7, how many elements you are going to expect? Yes, for period 7 also it should be 32, because when I am talking about 7s, so that's where 6, 5f, 6d and 7p. So these are the things which have to be filled, right? So 7s, 7p, then 6d and 5f. So 2 electron, 6 electron, 10 electron and 14 electron. All of you can see? Okay, it's not focused. Okay, so therefore even in period number 7 we will be having 32 elements. Even in period number 7 we will be having 32 elements. So therefore practice the Aufbau diagram. The whole story you can explain by using this particular diagram. Okay, so that's what I mean to tell, the importance of this particular diagram. Got my point? Any doubts? So therefore, how many periods are there in a particular modern periodic table? There are total 7 periods. So in the first period there are total 2 elements. Okay. In the second period there are total 8 elements. In third period once again there are 8 elements. Then period number 4 18. Period number 5 18. Period number 6 32. Period number 7 32 elements. All of you have understood? So therefore that's how elements have been distributed. And if you know the Aufbau diagram, you can explain it easily. All of you have understood? Okay, fine. So in that case, that's why I was telling that when in a periodic table, modern periodic table, when I am moving from one period to next period, that means in a group, I am moving down the group. So that means I am moving to the element which is going to next energy level. That's what periods indicates. Okay? All of you have understood? That's why we have 18 groups in the modern periodic table, and there are 7 periods in the modern periodic table. Now, those elements present in a particular group, they have similar properties because they will be having similar outer electronic configuration. When it comes to periods, those elements present in a particular period doesn't mean that they will have similar properties. Here only you can see hydrogen, helium belongs to same period, but they are totally different element. One will be considered as inert gas. So lithium, neon, both are present in the same period but totally different elements. So one is alkali metal and another one is inert gas. Same way everywhere it is applicable. Those elements present in a period will not have similar properties because they will be having different outer electronic configuration. All of you have understood? Any doubts? Any doubts, India? If you don't have any doubts, we will move to the next one. When we are moving to the next one, if a code diagram is required, I will rewrite it. When we are moving to the next one, that is with respect to different category of element, different blocks which are present in the periodic table. Okay. Now, as we have in Mysore, Vijayanagar, Gokulam, Kuvempu Nagar, like that different areas are there, right? Same way, in modern periodic table, we have different blocks of elements. We have classified periodic table into different sets of elements based on their properties. Say for example, we have one block as S block element. We have S block elements. Okay. Now, why they are called as S block elements? Because in these elements, I can tell that these are the elements. These are the elements where in their outer shell, S subshell is getting filled up. F subshell is filling up. Okay, so that's why they are called as S block elements. That's why they are called as S block element, because in their outer shell, S subshell is getting filled up. That's why they are called as S block elements. So in the model periodic table, we have group 1 and group 2, which belongs to S block elements. All of you have understood? Fine. So therefore, they can have the electronic configuration, general electronic configuration as general electronic configuration. For group 1, it will be NS1, and for group 2, it will be NS2. That's where S subshell got filled up, because S subshell is having only one orbital, so it can accommodate maximum 2 electrons. Due to that, S block elements will be composed of only 2 groups, group 1 and group 2, because when I am moving from group 1 to group 2, S subshell will be filled up. No further groups can be present in S block. All of you have understood? And group 1 elements are called as alkali metals, and group 2 elements will be called as alkaline earth metals. Okay? So alkali metals. Anyway, these things we are going to discuss separately. We have S block element topic itself. So here we have the alkaline earth metals. Alkaline earth metals. That's where sodium, potassium and all belongs. That's where magnesium, calcium and all belongs to. So that's where we have alkali metals and alkaline earth metals. They are reactive in nature. These elements, they are reactive in nature. Therefore, S block elements can also be called as main group elements. Or representative elements. All of you have understood? So main group elements or representative elements. Any doubts in this? Any doubts? So why in S block we have only 2 groups? Because S block will be having, S subshell will be having only one orbital, where only 2 electrons maximum can be accommodated. Therefore, S block elements will have only 2 groups within them. That is group 1 and group 2. One is alkali metal and another one is alkaline earth metals. Anyway, we are not going to discuss in detail. We have separate topic for these things. All of you have understood? That is related to S block element. So now we will move to another category. And we will move as that of the alphabets. SPDF. Means alphabet in the sense subshell. SPDF. We'll call it as SPDF, right? So first we have discussed S, then we will move to P. P subshell. We will move to P subshell. So P block elements. We have the P block elements. Now how to define the P block elements? So Dikshit, use the small alphabets. Don't use the capital. Okay na? So that's where we have the P block elements. So what do you mean by P block element? these are the group of elements. These are the group of elements where P subshell, in their outer shell, P subshell in their outer shell is filling up. So that's where we have the P block elements, where P subshell in the outermost shell is getting filling up with electrons. All of you have understood? Now, in S block we have total 2 groups. How many groups you expect in P block elements? How many groups you will be expecting with respect to P block elements? Anyone? In P block elements, how many groups you expect? In S block we have 2 groups. In P block, how many groups? Oh, Rohan already has given numbers. Okay? All of you will agree? But he has written, okay, number he has written 3 to 12. No. P block elements. So we expect, why these many different numbers? Harshita, you are right. And even Anju, she is right. All others are wrong. Why? In S block we have only 2 groups. Why? Because S subshell can accommodate maximum 2 electrons. In P block it should be 6 groups. It should be total 6 groups. That is because P subshell can accommodate 6 maximum electrons. 6 maximum electrons. Therefore, it should include 6 groups. Now, it will not start from group 3. It will not start from group 3. It will start from group 13 to group 18. Group 13 to group 18. All of you have understood? Therefore, in the beginning only I told, we are not going with one by one with respect to the groups. We are going with the SPDF. So S 1 to 2. But when it comes to P block, it will start from group 13 to group 18. Okay, that's fine, Rohan. That's fine. Okay, so that's why we have group 13 to group 18. Otherwise, for D block, what Rohan has told is correct. But that one will come later. Okay, na? So that's why we have group 13 to group 18. Fine. Now, speciality of this one is, it is having inert gas in it. It is having inert gas group in it. 0th group. We will call it as 0th group. Na. So we have inert gas which comes under P block. Right? So from group 13, where it will be NS2 NP1, and it will end up with NS2 NP6. NS2 NP6. And in between we have NS2 NP2, NS2 NP3, NS2 NP4, NS2 NP5, then NS2 NP6. So that's where we have the general electronic configuration for these groups. Okay, so that's where it will start from NS2. If I want to give the whole P block, I can write it as NS2 NP1 to 6. NS2 NP1 to 6. That can be the general electronic configuration for the whole P block elements. NS2 NP1 to 6. In that, group 13 will have NS2 NP1. Group 14 will have, that is carbon, NS2 NP2. Group 15, that is nitrogen, NS2 NP3. So like that it will goes on. All of you have understood? Any doubts in this? Okay. Now, speciality of P block element is, it is having in it metals, then metalloids, and even non-metals. That is the speciality of the P block elements. If you go with S block, I told alkali metals and alkaline earth metals. In both the cases, I am talking about metals. But when it comes to P block, this is the region where in the periodic table we can find non-metals. That's where we can find the non-metals. Please remember, P block is the only region in periodic table where we have the non-metals. Okay, so that's where we have metals, metalloids and non-metals. All of them they are non-metals. All of them they are not non-metals. Some of them are metals, some of them they can be metalloids like germanium and all, and then we have the non-metals. That means in the periodic table whose is going to dominate, metal or non-metal? So in the periodic table, metals are going to dominate with respect to the number I am talking about. With respect to the number, metals has to dominate, because in the P block, only that region where we have non-metals, and that also there is some elements which are metals, some elements which will be metalloids, but maximum P block elements will be non-metals. All of you have understood? So that's where we have the special character of the P block. In S block, it's only metals. Now, same as that of the S block, P block element, due to their reactiveness, they are called as main group elements. They are called as main group elements or representative elements or representative elements. We can call it as representative elements. All of you have understood? Okay, similar to that of the S block, here also due to that reactiveness and due to the presence of all the type of elements, that is metals, metalloids and non-metals, they are called as main group elements or representative elements. All of you have understood? So in that case, if I talk about group 13, this is the general electronic configuration for group 13. What about group 14? General electronic configuration will be NH2, NP2. Carbon is the example. If I talk about group 15, NH2, NP3, that is nitrogen family. Then group 16, oxygen family, NH2, NP4. Then comes the halogens, group 17, NH2, NP5. And finally we have NH2, NP6. So what is happening? So electrons start getting filled up in P subshell and it is ending up with completely filling of P subshell. All of you have understood? So if you observe group 13, NH2, NP1, that means NH2, S subshell was already filled because of the S block element. Then P subshell got started filling up. That's why group 13, P, 1 electron it has got. Then group 14, 2 electron in P subshell. Group 15, 3 electrons in P subshell. Group 16, 4 electrons in P subshell. Group 17, 5 electrons in P subshell. And at the end, 6 electron in P subshell. That's where the story is over, because P subshell can accommodate maximum 6 electrons only. Okay, so now whatever I have told, reason for this, they are reactive, that is not applicable for group 18. So group 18 elements are the one which are least reactive, therefore they are called as inert gas. Therefore they are called as inert gas. Fine? All of you have understood? With respect to this one, all of you have understood P block elements? Any doubts? Anyway, one P block element, group 13 and 14, you are going to discuss in detail in your part 2 chemistry, and rest of the P block element you are going to study in detail in second PU. Okay, in first PU you are going to discuss about S block in detail, that is group 1 and group 2. Then even you are going to discuss about group 13 and 14, boron family and carbon family. We are going to study in our first PU itself in a separate topic, part 2 textbook. Okay, and rest of the P block you are going to study in your second PU, and D and F block also you are going to study in your second PU. So any doubts here? Okay. So anyway, I'll stop here because if I continue, I cannot finish within 2-3 minutes. So I will stop here. What I will do is tomorrow we are going to discuss about D block elements. Tomorrow we are going to discuss about D and F block elements. Okay? Yes, Dikshit, you are absolutely correct. Since D subshell can accommodate 10 electron, there should be total 10 groups which will be present in D block. There should be 10 groups. Same logic is applicable for F block also, where 14 groups will be there. Okay? Okay then. So any doubts for any one of you? No doubts? Okay. So I will stop here then. Whatever has been taught until today, please go home and read it in your NCERT textbook also, check sheet also. Okay, practice. Okay na? So they are all very simple topics but very basic, which is very much required for your chemistry. So basic concepts of chemistry is over. Atomic structure of atom is done, which are also very important. Then periodic classification of elements we are doing. So try to practice. Okay na? So thank you. Thank you very much. Take care. Bye appa. Bye.